Okay, this is our second evaluation presentation.
Okay, so what's the problem with the current agile method? The problem is that there's a length of time assigned to story points, uh, which is the unit of productivity. So the issue is that developers are incentivized to rush their work to uh, reach story points within the given amount of time. And the way to fix this issue is to remove the length of time attached to story points to decentivize rushed work and incentivize valuable code that will provide value over a longer period of time. So what architectural style does Tor utilize? Tor uses a peer-to-peer architectural style. We know this because it uses nodes to relay web traffic um, throughout them. So this also grants anonymity for the user. This is because the user's client, the computer, is basically indistinguishable from other uh, nodes in the network, which makes it very difficult or impossible to tell who the user is.
Some modern programming languages like Rust and Go have taken a composition over inheritance approach to object-oriented programming, meaning that they prefer to implement interfaces and abstract classes instead of traditional inheritance. Rust and Go adopt the composition over inheritance approach to promote cleaner and more maintainable code and reduce code smells. Inheritance can often lead to violations of solid principles, like SRP, because subclasses inherit all behaviors of the superclass, which can result in multiple and unnecessary responsibilities being held by the subclasses. This tight coupling also conflicts with the open-close principle, as changes to the base class can force modifications in subclasses, which is no good. Composition, on the other hand, allows for flexible code design and enables programmers to assemble objects with specific behaviors without inheriting irrelevant methods. So, in a system with high coupling, high-level modules are often directly dependent on low-level modules, making the system inflexible and hard to extend. This often results in code that is tightly bound together, meaning that changes to low-level modules can impact high-level modules as well. With high coupling and low cohesion, there is a much greater likelihood of introducing bugs when making changes, as small changes in one module can have wide-ranging effects on other parts of the system. Inconsistent or poorly designed code is prone to errors, and these bugs can be difficult to trace back to their origin. Refactoring the code base to be more modular and flexible will allow the company to scale more easily by adding new features or expanding the team without significantly increasing the risk of system failures. When you refactor code to improve cohesion and reduce coupling, you're effectively addressing multiple solid principles. One is modularizing the system. Two is ensuring that classes have single responsibilities. And three is by introducing abstractions. These solutions can make the codebase easier to understand, extend, and maintain. Refactoring also promotes cleaner architecture, leading to more scalable and sustainable codebase.
So let's look at a behavioral pattern, the observer design pattern. This is when subjects change states. It will also notify all of its observers about the event or action of changing its state. In this scenario, the subjects are the microservices because the logs that they published to the single logging service lets the observer logging system to receive the logs and react to them. So here are some examples. A Nest security camera. A developer that wants to develop an app where it will send notifications to the user when a security camera spots a person, car, or movement. The subject is the camera sensor. It monitors the movement of the people, car, and activity. It notifies the observers that the movement has been detected. The observers are the user's cell phone, smartwatch, or any digital device that reacts to the change of the movement from the camera. Thermostat system, another example. A developer developing thermostat system would be an example of an observer pattern. The temperature changes in the house through the temperature sensors. The observer would be the AC heating system depending on the time of the season.
To talk about the strategy design pattern next. So this strategy design pattern enables an object to choose from multiple algorithms and behaviors at runtime rather than just selecting one when you're coding it. So based on this design, you can have a module that has interchangeable pieces, and when the code is executing, whenever the user makes a decision, we select a strategy to run based on that. So now I'll go over some examples of this strategy. So you can first think of some type of image rendering platform. And of course, with images, you have a ton of different formats like JPEG, PNG, and GIFs. And in order for the application to receive the data from these formats, you can code up the methods that extract data from each of these files separately. And then whenever the user tries to open a certain version of that file, we select the strategy and the method that we're going to be using to open those files at runtime. So if the user clicks on JPEG, we look at how do you open a JPEG file and go to that method. So that would be the first example. And secondly, if you're making some type of application to showcase the performance of different sorting algorithms, you can design the implementations of all of these algorithms differently. And then when the user wants to test these out, you can select those at runtime and the code execution will follow based on the selected design. That's it.
So a mobile app that we chose to describe its architectural style is Discord. So Discord is primarily a client-server architecture. According to the Discord blog, it states that supporting large group channels requires client-server networking architecture because peer-to-peer networking becomes prohibitively expensive as the number of participants increase. So we look at the scalability of it. Discord has servers that allows users to respond to clients' requests in terms of joining group channels, voice channel, and text channel. Discord distributes the load across many servers. The set of clients. Clients are the desktop app, mobile app, or web browser that the Discord use that they can call on these services. So to explain the following testing stages of developer, alpha testing, and beta testing, we see that each stage has the purpose that makes the feature stable, user-friendly, and ready for deployment. In the developer testing, the purpose of the developer testing stage is that the developer writes their test cases for each individual component of the new feature. This allows the developer to also ensure that anonymous feedback are processed correctly. The alpha testing. So the quality assurance developers actually test out the new feature extensively to identify any major bugs or errors in terms of the user interface, the platform, and the backend. Lastly, the beta testing. The purpose of the beta testing is to see if the product at its finalized stage is acceptable or receive criticisms. If the potential users enjoy the new feature, then the developers can fix minor bugs or issues or maybe even improve upon it. If not, they would improve massively upon the new feature. And this is our second evaluation presentation.